Now we're going to add something to our unit circle. Notice that each point on this unit circle where each of the special angles cross the circumference is associated with a particular ordered pair, a certain point on the circumference of the unit circle. So we're going to look in general about what those points tell us. So first of all, I'm going to make a little unit circle up in the corner here, and I'm going to label it an angle theta. I'm going to need to make this bigger. Oh, I've got more space than I realized. Okay, here we go. Label this angle theta. I'm going to drop a perpendicular line down to make a right triangle. So here's my angle theta in the corner. This distance is x, this distance is y, making me have a point x, y. And since it's a unit circle, my hypotenuse is 1. That means if I find trig values, cosine of theta is equal to x over 1, which is just x. Sine of theta is equal to y over 1, which is just y. And tangent of theta, which we'll talk about more tomorrow, is y over x, because we're talking about opposite over adjacent over hypotenuse for cosine. So adjacent side over hypotenuse, opposite over hypotenuse, opposite over adjacent for tangent. Now that means that whenever I have a unit circle, a circle of radius 1, that the cosine value and the sine value of any angle are the coordinates of the point on the circumference. So let's take a look at this first angle here when we have an angle of pi over 6 or 30 degrees. So we know this angle right here is 30 degrees. So I can create a 30, 60, 90 triangle with that. So I'm just looking at this little section here. That's a 30, 60, 90 triangle. Which means, and if we look at our sides of a special triangle, opposite 30 is 1, opposite 60 is the square root of 3, opposite 90 is 2. Looking at that, cosine of 30 is square root of 3 over 2, and sine of 30 is 1/2. Now this right now is not a part of a unit circle because the radius here would be 2 if this were inscribed in a circle. But I can make a similar triangle, in other words, a triangle with the same angles but a different side lengths. So kind of smaller like this. And I could divide each of these sides by 2. So if I divide the horizontal side by, or the vertical side by 2, that would be 1/2. If I divide the horizontal side by 2, that'd be the square root of 3 over 2. If I divide the hypotenuse by 2, it would be 1. Same angles in the triangle. This is still 30 degrees, but now it fits in a unit circle. And so that means that if I go over x and up y, the point on the unit circle is the point square root of 3 over 2, 1/2. So that's what I just did right here. Over x, up y in a 30-degree angle. This has a hypotenuse, has the radius of 1, so that's the hypotenuse of my triangle. If I were to, say, make my triangle look like this, so here's the triangle that I just made, like this. The coordinate, and this is 1, and this is 1/2, and this is the square root of 3 over 2. So this point right here is square root of 3 over 2, 1/2. I can do the same thing with a 45, 45, 90 triangle with my pi over 4 angle. And I'm not going to draw that on the unit circle, but if I were to make a 45, 45, 90 triangle, I know that this is square root of 2, 1, and 1 for a 45-degree angle. So sine and cosine are both 1 over square root of 2, or square root of 2 over 2 if I rationalize the denominator. Now if I were to divide each of these sides by square root of 2 over 2, divide each of the sides by square root of 2, I would end up with 1 over the square root of 2, 1 over the square root of 2, and just to remind you, 1 over the square root of 2, if I rationalize the denominator, is equal to the square root of 2 over 2. So both cosine and sine are the same value, so both of those are square root of 2 over 2. When I get to a 60 degree is just the 30 degree turned the other direction. So now the tall side here, or the y value is going to be square root of 3 over 2, and the short side is going to be 1/2. So this is square root of 3 over, I'm sorry, 1/2 is the cosine value, 1/2 and square root of 3 over 2. So the sine and cosine values are found by the coordinates of the point on the unit circle. This is cosine goes with x, and sine goes with y. So if I wanted to find tangent, I could just do y divided by x, and I would have tangent. So notice that everything in this first quadrant gives me positive trig values. So in quadrant 1, we're all positive. Sine, cosine, and tangent, all positive. Now, let's take a look then. We can't make a triangle when we're at 0 degrees or at 90 degrees. I can't make a 90-degree triangle where the angle here is 90. The angle at the center has to be the acute angle, and then the angle going down has to be where the right angle is. So I can't do that with 90. I can't do that with 0. So I just have to use the coordinates. So the point at 0 is the point 1, 0. So that would be my cosine value would be 1, my sine value would be 0. At 90, I'm at 0, 1. So think about this. The cosine represents the adjacent side. The adjacent side here is completely adjacent, so it's 1. There's no opposite side. There's no vertical side. Here the vertical side is 1, and there's no horizontal side. So 0, 1 with sine being 1. Now going into quadrant 2, we encounter angles that are obtuse. I can't form a right triangle, so I have to use reference angles. So 150 or 5 pi over 6 has a reference angle of 30, or pi over 6. 3 pi over 4 has a reference angle of 45. 2 pi over 3 has a reference angle of 60. So their sine and cosine values are going to be the same, except for the fact that cosine, or the x value, is negative in quadrant 2, because we're in the negative x direction. For example, this is negative 1, 0 here. So we take these points here, square root of 3 over 2 and 1/2, transfer them over to the other angle with the same reference angle, but now the first one is negative. So negative square root of 3 over 2, 1/2. Negative square root of 2 over 2, 1/2. Negative 1/2, negative square root of, or positive square root of 3 over 2. Sorry, that one has to be positive. Square root of 3 over 2. So in this case, we have in quadrant 2, sine is still positive because the y value is still positive in quadrant 2, but cosine is negative. And if sine represents y divided by x, I'm sorry, if tangent represents y divided by x, then tangent also would be negative because it's be a positive divided by a negative. So in quadrant 2, sine is the positive one. When we go to quadrant 3, both the coordinates are negative. Notice we have 30-degree reference angles still here. So 7 pi over 6 and 5 pi over 6 are going to have the same trig values, except instead of the y being positive, now it's going to be negative. So negative square root of 3 over 2, negative 1/2. 45 degrees, both the same, but both negative. Negative square root of 2, negative square root of 2 over 2. 60, negative 1/2, negative square root of 3 over 2. In quadrant 3, notice both sine and cosine are negative, and since tangent is y divided by x, tangent is going to be the thing that's positive in quadrant 3. Sine negative, cosine negative. When we go to quadrant 4, now sine is positive because the adjacent side is the horizontal side, that's positive. The opposite side, the y side, which denotes the sine value, is negative. Notice 11 pi over 6 has the same trig values as 7 pi over 6, 7 pi over 4 matches 5 pi over 4, 5 pi over 3 matches 4 pi over 3, because if I drop a perpendicular line down to the x-axis, or up in this case, they would have the same reference angle. So I'm going to go ahead and start with 0, negative 1 for 270. This 5 pi over 3 would be positive 1/2, negative square root of 3 over 2, positive square root of 2 over 2, negative square root of 2 over 2 for the 45-degree angle here, and positive square root of 3 over 2, negative 1/2 for the one with a 30-degree reference angle. In this case, cosine is the positive one. So in quadrant 4, cosine is positive, sine and tangent are negative. Now just to show you one interesting little pattern, you'll notice that we're always counting from 0 to 1/2 to square root of 2 over 2 to square root of 3 over 2 to 1. If we go the opposite direction with cosine, 0, 1/2, square root of 2 over 2, square root of 3 over 2, 1. There's something interesting about that little pattern. If we go 0, 1/2, square root of 2 over 2, square root of 3 over 2, 1. Let's turn them all into fractions where the numerator is a square root and the denominator is 2. So we can write this as the square root of 0 over 2, which is just 0. The square root of 1 over 2, which is just 1/2. The square root of 2 over 2. The square root of 3 over 2. The square root of 4 over 2, because the square root of 4 equals 2, so the square root of 4 over 2 is 1. So there's a nifty little pattern that occurs with these numbers. Now, an example problem, well, first of all, let me say that many of you will be able to memorize this table and just know what the pattern is and use the table to figure out sine and cosine and even tangent values easily by just knowing what the unit circle pattern is. Others of you will find that much more difficult to do. And so I would suggest if I give you a problem like this, and you will be given a problem like this without a calculator, without notes, and I'll say, find sine of 7 pi over 6. So you have to know that sine is opposite over hypotenuse. You have to know pi over 6 is a 30-degree angle, and 7 pi over 6 is in quadrant 3, and you have to be able to know your special triangles. There's a lot of information you have to know to do this problem. What I would always say to start with, though, is make a picture of where 7 pi over 6 is on the unit circle. So 7 pi over 6 is pi over 6 more than 6 pi over 6, and 6 pi over 6 is just pi, and that's 180. So 7 pi over 6 is in quadrant 3. This would be, we associate pi over 6 with a 30-degree reference angle, so I can draw a 30, 60, 90 triangle. Opposite 30 would be 1. Opposite 60 is square root of 3, and the hypotenuse is 2. The hypotenuse is always a positive number. It just represents the radius. The other two numbers, though, have to be marked either positive or negative depending on which quadrant they're in, and we're in quadrant 3, so both of these numbers are negative. So I can just read my special triangle here and just say, well, sine is opposite, and remember we're always looking at, this is our angle that we're looking at, the one that's attached to the vertex. So opposite would be always the vertical side. So negative 1/2 is our sine value. Now, if you remembered the unit circle pattern and remembered, okay, in the unit circle it's either going to be 1/2 square root of 2 over 2 or square root of 3 over 2, and you kind of look at the unit circle and you say, I'm looking at this opposite side. Notice that if I make my angle bigger in quadrant 3, that opposite side gets bigger. So I'm looking for the smallest of those three numbers, which would be the 1/2, and I know it's negative. So there's different ways of looking at this. I didn't use a unit circle here. I didn't use that the radius of 1. I could have divided everything by 2, and then I would have had a unit circle. Negative square root of 3 over 2 is my x value, that's cosine. Negative 1/2 is my y value, and that's sine. I've included some good things on the website too, so you might want to check out on the website some other practice activities on the internet that will help you with the unit circle.